Hello and welcome back. I'm Pat, and this is my series on exploring a variety of topics to prepare for my senior computer science capstone coming up in the fall. In the last video, we created a character controller with a focus on procedural animations. And in this video, we'll be setting up our camera system. Let's start off by moving our camera throughout the world to follow our player. If we just look at our inspector, these values might not be intuitive at first glance. So let's think about how we got to this orientation to begin with. We'd start by parenting our camera to the player to zero out our position. Then we rotate our camera to the angle that we want. After that, we change our pivot from global to local before we push the camera backwards on the z-axis. Finally, we unparent our camera, where we end up with these funky position values. We can do this through code as well. For a minute, let's assume that the camera is already rotated the way we want it. We'll circle back around to this in a bit. Anyways, let's declare a vector3 to represent that z offset. To transform the offset, we'll need to do some linear algebra matrix multiplication with transform.local to world matrix. Now that we're in this state, we just need to add in the player's world position to offset us to the right spot. And voila, we have camera following movement. Since our camera follows us perfectly, let's go ahead and add some interpolation to smooth out that movement over time. This next feature I want is going to be a bit more future-proofy for some ideas I have down the line. I want to use the camera as a tool to slightly nudge the player's attention towards something. My idea right now is to use focus targets. When active, provides the camera controller with details on what exactly to focus on. If we want to hint a key item, we can just take an average between the two targets' positions. So we'll code up an interface. For the item we want to highlight, we'll create a focus region that uses a sphere trigger to keep track of whether or not the player is in that area. Now, if we have a bias of which target to focus on, we can change our regular average into a weighted average. By lowering our region's weight, the focus will be put up towards the player. If we increase our region's weight, we'll get closer to that region's center. To wrap up our focus region, we'll add some easing based on how long the player has been in that region. Once the player has left, we'll decrease that time until it reaches 0. At that point, the trigger will let the camera controller know to remove it from the listing. With that, let's circle back around to camera rotation. If you've ever tried to do anything rotation related and wanted to know how to mess with quaternions, I can almost guarantee you that the first answer you'll get is nope, it's too complicated, stick to using Euler and cross your fingers. Now, I found myself as a programmer that doesn't like to work with black boxes, so after looking into that box with a mathematical background, my newfound perspective is, you better cross your fingers even harder. Now, real talk, I tried to squeeze in a rambling on quaternions into this video, and it turned into a bulk of the script and a lot of mathematics, so I think I'm going to make a different video on that in the future, if I can make it coherent enough. But I do want to highlight on two ways to use quaternions in game development. If you have two rotations and you want to combine them, just multiply the two quaternions together. But be careful because the order does matter, so you may need to brute force your way through the options. Now, do you want to rotate a vector? Well, you can multiply the quaternion by that vector. Luckily, this is the only order you can have this as the other option doesn't compile. Why is that? Well, the short answer is linear algebra matrix multiplication. Anyways, back to cameras. To build our rotation, we'll create a quaternion from a vector3 for pitch, yaw, and roll. For now, these features will stay in the background for cinematic tools I'd like to develop in the future. Now, if hearing me talk about quaternions for even a second scared you, let's add some camera shaking. There's two types of camera shakes you can do. I'm opting for translational camera shaking over rotational camera shaking, because 1, it avoids another quaternion implementation, and 2, the severity of the rotational camera shaking would be dependent on how close the camera is to the player. For a quick implementation, we sample a random point on a unit circle to translate to, and then we multiply that by a magnitude decreasing quickly over time. These two camera shakes may even be too much, but that's alright with me. For right now, it's a nice feature to have that I can have up my sleeve and that I can tune up later. Oh, I almost forgot, we'll need to do another local to world matrix multiplication, so our shaking isn't zooming in and out. And speaking of zooming, let's add some zoom controls. The big quirk of our implementation is how I'm doing this down-res visual. For my main camera, I'm rendering the game into a lower resolution render texture with a filter mode set to point. This filter allows our render texture to be scaled up without any blurring of the image. This render texture is then re-rendered by another camera that outputs to the screen. Now, zooming in by pushing the camera back is alright, as things get more pixelated. But as we zoom in, we lose our alias pixelation effect due to everything just being so much larger when we're so much closer. To get around this, we need a piecewise zoom, where zooming out moves the camera back like normal, but as we zoom in past a certain threshold, we want to start scaling up our render texture's game object. After remapping the zoom's value range with this easing function, we get this look and feel as once we get closer to our boundaries of our zoom, we start slowing down a little bit. Now, for one final feature, I noticed something when I was looking at other games. Jumping doesn't always affect the camera movement. After realizing that, I just had to sneak in one final feature. Let's add some extra functionality to the player focus target. We'll take in a reference for the player mover to get access to the isGrounded property. With this, we have a camera only move vertically when the player is grounded. However, if our player is moving a long way vertically, we get a quick camera movement to get back to the player. Instead, we'll clamp our max distance, so we'll follow the player when their vertical displacement is past a certain threshold. And with that, we've got a nice camera system to prototype with. So far, I think pre-development is going nicely. For now, I do want to take a break from player mechanics to have some more fun with aesthetics. If you're interested in more of these videos, consider subscribing. In the next video, I'll hopefully be diving into compute shaders. Until then, have a nice day, and I'll see you in the next one.